Hi Majunya, this is the solution for the one that you sent me. There, I put in that sketch that's in the exercise there, which is the one of that you asked about. I've divided the section into its various sections. If I look at your sketch there, I think it's important to there's a triangle, and its dimensions would be 80 by 100. Okay, the rectangle will be 120 by 80. Sorry, 120 by 100, and of course the circle, its radius will be 40. Okay, right. So, and the dots there, that's the centroidal position of where they're sitting. Okay, right. So I notice you did it by a table. I'm gonna do it by a just you done it by just by the long calculation. I'm gonna do it by the long calculation, and I'm going to call this element 1, and I'm going to call this element 2, and I'm going to call this element 3. It doesn't matter which one you call which one, just take all of them. Right, bar y. So bar y is equal to the sum of right. So that's the element, the area of the elements. I'm going to take 1, so the area of the triangle is half 80 times 100, half times 80 times 100. And that y there, remember we're doing bar y, we're considering all vertical distances only. Okay, so that y there is the distance from there to there. Okay, now if you go to the table, which looks like this. Okay, if you go to the table there, okay, you'll see there that from the bottom to there, well, they don't show it there. If from there to there is 2/3 of d, then the distance from the centroid to the bottom is 1/3 of d. Okay, so that's going to be so the distance from there to there is 100 over 3. So I'm going to work it out quickly. It's 100 divided by 3 is equal to, so it's 33.33. So it's 33.33 plus. Why is it plus? Because it's the sum of. Right. Element 2. Its area is 120 times 100. So it's 120 times 100. What's y? Y is the distance from the centroid to that line we're taking moment areas about. You chose it as A. That will be 50. Okay. Why is it 50? Because from the table, it's half the distance. 50. Right. And when we have a cut out, it's minus. Very important minus. Okay. Minus. Okay. So what's the area for the semicircle? Right. The area, the formula for the area of a circle is pi r squared, but that's a semicircle, so it's half pi r squared. What's the radius? The radius is 14. Half pi r squared times. Okay. And what's y? Y is the distance from the centroid, which is there. The distance from there down to there. Okay. And of course, if you go to the table of section properties, okay, you can either use this or this, but the distance for us is 4r over 3 pi. Okay, so I'm going to pause it quickly and work it out. So the y distance from the centroid to the line we're taking moments of out is given by 4 times 40 over 3 pi. Okay, and I get 16.98 millimeters. Okay, so it's 16.98. There's no more, so it's all of that over the total area. So it'll be half 80 times 100, half times 80 times 100. Because remember that bit's there, that bit there, and that bit there, it's just the area of each section, okay? Times 100 plus 120 times 100, which is the area of the rectangle. And very important, minus, okay? Minus half pi r squared, half pi times 40 squared. Okay, is equal to. Right. So work at the answer. Check, see what you get. Let me just pause this for a second. And if we look at the answer, Mazunia, I get 51.21 millimeters. Okay, so all of this divided by all of that, 51.21 millimeters. And if I flash back to the answer quickly, there's the one answer, bar 1. Okay, now this answer here means that we work this from that point upwards like in your exercise. Okay, so that's how we get that answer there. Okay, now just watch this. I'm going to draw in that axis. What does that mean? Let me just do this quickly here. What this means here, I'm going to draw in, okay, which I normally teach this only at toss level. So I'm going to draw the line like so. And I draw a line like say so. Now this 51.21 Majunia is actually the distance from there all the way up to there. That's what it actually means, okay? And that there is actually the x axis of that whole section. And that vertical one there is actually the y axis of the whole section over there, okay? So of course, if the distance from there to there is 51.21 millimeters, then the distance from the x axis to the topmost fibers must be equal to that. Take it away from 100. So let's do that quickly. I'm going to say minus 100. And I get 48.79. Okay, so the distance from there to there is 48.79. Okay, so Mazunia, if you worked from this point down here, you would have gotten that one. Okay, but we work from this point up, we got that one. Okay, so what I'm saying is, so when you work horizontally, you're going to get the distance from there to there and from there to there. So the sum of those two will be equal to the full distance, which is 200, and the sum of those two is equal to the full depth of the section, which is 100. Okay, so when I mark this in the exam, I look for that answer or that one, and both is correct. Okay, so now I'm going to do the horizontal. I'm going to work the distance from there to there and find the distance there. Okay, just give me a second. Right, I'm going to squeeze it all on one page. Right, so bar X, let's see. It's in the red. I'm going to leave it in the red myself. I can leave it red now. Bar X is equal to the sum of over the total area. Okay, right, here we go. Right, let's see. Let me change this to blue rather. Right, so area of section is half 80 times 100, same like future, half times 80 times 100. And of course, if you're doing this in the table, you'll do this but once only, times x. What's x? X is the horizontal distance from the point we take in moments about to the centroid of that. Okay, now from there to there is 1/3 of 80. Okay, so I say 80 over 180 divided by 3. But it's plus the distance from there to there. Remember, x is the distance from the centroid to the line we take in moment areas about. So from there to there is it's 80 over 3 plus the 100 plus, my apologies, plus 120. So from there to there is 80 over 3 plus 120. So it's 80 over 3 plus 120. Let's see. And I get 146.67. So it's 146.67 plus. Why plus? Because it's the sum of. Right, area of rectangle is 120 by 100. 120 by 100 times the horizontal distance from the centroid to the line we taken moments about, which is half of that, which is 60. Minus. Right, I'm going to squeeze it in here. Right, area of semicircle is half pi r squared, half pi times 40 squared. times the distance. Now remember the centroid is sitting on that line there. So it's from there to there, which is 40 plus 20, which is 60. Okay, 40 plus 20, which is 60. All of that over the total area of the section there, which we got from there. Okay, so you can just record it in there. And the area that I calculated from the previous one was 13486.73 millimeters. Okay, and it's equal to, and the answer I get there is 85.71 millimeters. Don't forget to write the millimeters in. A lot of people leave it out. I take up a mark. That's minus 1 mark. That's minus 1 mark because the distance. Okay. What does that mean? It means this. Means that, okay, if I just draw this here, means the distance from there to there is 85.71. That's what it means. Okay. But what does it? So what does it also mean? It means that this, we can now also work at the distance from the centroid to that end there. Okay. And how do we do that? We take the full width, which is 200 minus 85.71. Take 200 away from that, and I get 114.29. 114.29. Okay. Let me check the answers quickly. Okay, there's the answers. There we go. Okay. So this here, this is answers that's given by the author of the book. So that distance is the distance from that point up to there, and that x is the distance from there to there. So, my junior, if you made this your point A here, okay, you would have gotten these two answers here, okay? Bar y 51.20, bar x 114.30. We got 0.29, that's good enough. Okay, but because you worked from here, you got this one and you got the other one. If you work from this point down here, you've gotten 48.79, 85.71. If you work from this point here, you would have gotten that one and that one. If you work from this point here, you would have gotten this one and that one, which is given there. Okay, so my junior, so as I said in my note to yesterday, whenever I mark this problem in any test, I always work at all four. I work at these two and I work at the other two, and any pair, this, okay, I mark those. And if you got any pair and it's correct, I'll mark it as correct. Okay, I'll try and work quickly on your next one that you asked me about. I'll see you in the next video.